How do you differentiate the fourth root of x from first principles? This is not that hard. If you remember how to differentiate just the regular square root of x from first principles, you're going to need to do some rationalizing. So to start this off, what we should do is we should remember the way that first principles works. So we'll let this function equal f. Therefore, what first principles states is that f dash is given by this particular function when you take a limit on it, namely f of x plus h minus f of x all over h. And what this represents here, this is the regular way that we work out gradient. It's rise over run, but we're thinking about the run as it gets increasingly smaller. So that's why you take the limit as h approaches 0. Now, in this case, if we make f the fourth root of x, what happens here? Well, what I'm going to have is, this will be the derivative of the fourth root of x, okay? Everywhere I see an f, I'm going to put in the fourth root of whatever that is there. So have your limit there. It's very easy to forget your limit. Don't do that. You're going to have the fourth root of x plus h minus the fourth root of x all over h. Now, this looks hard to deal with, but I can use difference of squares. If I multiply here, I can try to rationalize what's happening here. So what I would multiply by to take advantage of difference of squares is the conjugate of this numerator. So that would be the fourth root of x plus h plus the fourth root of x. Okay. Now, when I multiply these two together, difference of squares is going to simplify it, but you can't just multiply the top, you've got to do the bottom as well, otherwise you've changed the fraction. So there we go, multiplying by that over that, no change. So what happens on the numerator? Well, write your limit in. Because this is in the form a minus b, a plus b, right? That's what difference of squares is. I should get, when I expand these together, I should get a squared minus b squared. That's what difference of squares is. But since my a is the fourth root of something and my b is the fourth root of something else, a squared minus b squared will be just the regular square root. That minus that. That's my a squared and that's my b squared, right? So if you can't quite see that, you know, this fourth root of x plus h, you could rewrite that as x plus h to the power of a quarter, right? So if I squared this thing, then I would square this thing, okay? But the way the index laws work is that you're going to multiply those two powers there, 2 over 4, which is a half. So that's why that's the square root of x plus h, which is what I have here. Okay, so that's what's happened to the numerator. What's happened to the denominator? Well, that original h is still there, and then you've got all of this junk on the denominator, which looks like it'll be bad, but if we stay with it, it should simplify out. Okay. Now, my goal here is to be able to get rid of this h in the denominator, because while it's in the denominator, I can't evaluate the limit. You can't stick 0 into the denominator because division by 0, it doesn't work. We don't know what that means. That's what the calculator says means when it says undefined. So in order to do that, I need to rationalize this further. I still haven't rationalized it. I got rid of the fourth roots, but I've got square roots. So to do that, I'll do the same trick again. I'm going to multiply by the conjugate of the top. That, in this case, will be square root of x plus h plus the square root of x. And, of course, if I multiply the top, I better multiply the bottom. Okay, so this is what I've got. So now on the top, difference of squares again, it's a minus b, a plus b. So I'll get a squared minus b squared here, which is x plus h minus x. There's my a squared, and there's my b squared. All over, now you have this really disgusting thing all on the bottom. You've got these two, the two fourth roots. Then you've got these two, the square roots. Okay, now this doesn't look good, but we can work with it. For instance, on the numerator, you've got an x here and a minus x there. So that guy and that guy are going to cancel. So all I have is h now. But if all I have is h, I've got an h on the numerator and the denominator, so that'll cancel with that, just leaves me 1 on the top. Now that's really good, because if I've gotten rid of the h on the denominator, which is what I was trying to do before, I can evaluate this when h equals 0. I can put h equals 0 into all of the places where h is now. So my next line doesn't have limit anymore. I'm actually going to say, now let's consider what happens when h equals to 0. I'll have the fourth root of x plus 0. there plus the fourth root of x. And then over here, I'll have the square root of x plus 0 plus the square root of x. Okay. All right, what does that work out to be? Well, 1 over, this is 2 lots of the fourth root of x, right? Because that's the fourth root of x and that's the fourth root of x. I've got 2 of them. Multiplied by 2 lots of the square root of x, like so. Okay. Now, these are going to interact with each other. It's probably easier if I put it into index notation. I've got 2 times 2, which is just 4. This is x to the power of a quarter, and this is x to the power of a half. So index laws tells me I should add these 2 numbers together, and I get 1 over 4x to the power of 3 over 4. Okay? Right, so there you go. That's how I went through it by first principles. I can check whether I was right or not because I know how to deal with this kind of function and how to differentiate it without first principles. So all I need to do is think about the fourth root of x. It is easier to think about it as x to the power of a number because they're really easy to differentiate and it's just a quarter. So when you differentiate x to a number, x raised to a power, you bring that power out the front and then you reduce the power by 1. A quarter minus 1 is negative 3/4. But that negative, that means this should be on the denominator. So this is actually 1 over 4x to the 3 on 4, which is exactly what I got before. So that's how you do this by first principles. It's a bit longer than doing the square root of x because you have to do this twice, but it's exactly the same kind of difficulty. You get your answer at the end.